Well, hello everybody, and welcome to this episode of G-Bear's Off-Grid Ways, a homestead in the desert. And what are we doing here? Well, I decided I was going to come in here and show you the little burnt connector again. It's not loose. It's not the wires aren't burnt or anything. I don't know. It probably got hot in there at one point. But I will, on a day when the winds aren't blowing, I will be taking that apart and soldering it. But that's not truly why I'm here. I'm here because I'm going to address some questions I got from Emma, Jason, and Matt, who go to Lehigh University in Pennsylvania. And they are working on a group project with six students. I named three of them because that's the only three I've had contact with. And their project is they're going to be putting together a wind generator, and they're going to use a vertical access system, which is a little different than mine. Mine is a horizontal access PMA. Now, they sent me a list of materials, and I want to start off by addressing that. Matt was the last one who sent me the information, and then I went online and I looked at the generator that they purchased. It's a 12/24 volt generator. Okay. Now that could mean two things, and you might want to, Matt, you might want to call and speak to the seller first and clarify. Okay, a 12 volt generator, it would be a PMG. Now they listed this one on the link that you gave me as a PMA, but they call it a generator to start with. So I'm assuming at that point what they're talking about is that this is a rectifier that changes a PMA, an alternator, to a DC output. Now a PMG, or a generator, will only have the red and the black wires coming out of the generator itself, instead of three wires the same. And what that would mean is this little rectifier unit is actually built right into the alternator on the top, and it's already being changed to DC before it comes down to you at the bottom. Okay, now the thing about a generator versus an alternator is, on an alternator you can use much smaller wiring, and you can come down with, I'm using 6 here, but I could have come down with 10 gauge and it would have been adequate for the distance I had to run. And the distance determines how much conduction you're going to need, how thick of a wire you're going to need. So if I was doing 2 or 3 times the distance that I'm doing from here, I would have had to upgrade to a 6 gauge from 10 gauge, but 10 gauge was adequate for this setup. All right, now this is the meter I was telling you about buying. Okay, so if you're using a generator, then you're going to forget about the 3 wires here coming into the rectifier, because you're not going to see those. You're going to have a red and a black coming out of your motor or generator. That's a generator itself. Okay, so that all you're going to have is these two. So those two that come out of your generator are going to go into the positive and negative on the input side of your gauge. And then coming out of that, you have a red and a black that go to the battery. Okay, now those go straight to the battery. You do not need a controller. You don't need a controller like this in between. And you don't want to use a controller, whether it's a PMA or an MPPT controller, for a DC unit, because the controllers are designed for solar. Okay? That's why they have the solar panel on there, and they don't have a icon showing a 3-blade propeller. Now this one is an MPPT, and it's a hybrid. So this one has the solar down here, and then it has a connection for the wind turbine up here. But it's for a PMA. It has a built-in rectifier, so it takes 3 wires in. So you would not take a generator and put it in where solar is supposed to go, because you're going to have fluctuating voltages. That being said, let me get into the next thing here. Okay, when you're building a PMA or a wind generator, wind turbine, whatever you want to call it, there are a few things that you have to make sure of. Number one is the output of the generator itself. As yours is listed at 12/24. Now that could mean a couple of things. It could mean that on the back side of it where the wires go in, you have to switch the wires around to two different connectors to get 24 volt output. Or it could mean simply, and this is what it probably means, is that it's rated for 12 volts at X RPM. Okay, so let's say 300 RPM. It'll put out 12 volts. If it does that, then at 600 RPM, it's going to double the voltage to 24 volts. All right, so that's how you're going to set up your turbine and determine what your output requirement is going to be for what you want to do with it. Now, whenever you talking about these things, you're talking about open circuit voltage or short circuit current. Now, open voltage circuit means, let's say you had these two wires coming down from your generator and you had them connected to absolutely nothing, and you put wind to the generator. Well, then you put your voltmeter, this is your voltmeter, on volts, and then you read on DC volts, and then you read across those two wires coming down from the generator, the motor, as it's turning, and you read that voltage. Okay, so that would be your open circuit voltage. In other words, it's an open circuit. It's not connected to anything. It's not being drawn down by any load on it. Now, once you connect it to batteries, then it's a closed circuit value. It's no longer an open circuit value. So to determine the watts on your output of your wind turbine, you would take the reading from the battery bank at that point, not from the input wires coming in. All right, I hope that's not confusing you. You know, there was a link to a great informational page that gives you all this information that I looked at when I first started into this. I'll see if I can find that, and I'll put it down in the comment section below this video so that you'll have something to refer to that'll give you all this information. The thing that you want to determine is what the maximum speed of your motor is, or your generator is, to put out the 12 volts that you're going to need to charge your batteries. All right, so you're not going to be needing a controller in this anywhere. You're going to go from your generator through your gauge so that you can get some readings on it. Like this one right now is showing that we're making 157, 178 watts, 200 watts. So that's what's going on outside. And this is the amps that I'm making out there. So this is closed circuit stuff. So if you take the amps and multiply them times the volts that I'm making, like 6 times 13, you'll come up with the watts. Okay, so that's the Ohm's law. And I know you guys said that you weren't electrical engineers or anything like that, but you need to know about Ohm's law. And the Ohm's law, a simple pie chart that we learned when I was learning electronics was, okay, let's draw a pie, and then we're going to cut the pie in half, and then we're going to cut the bottom half in half. So up here we're going to have P, I, E. Okay, P is power, the I is input or amps, and E is energy or volts. Okay, so this is going to be your watts. This is your current or amps. And this is your volts. Oh, okay, so in other words, all this is telling you is that if you have your watts, the amount of watts number, and you divide it by your amps, it'll give you volts. If you have your watts and you divide it by volts, it'll give you your amps. If you multiply your amps times your volts, it'll give you your watts. All right? Very simple. So that's some good information. That's Ohm's law. That's something that you really should know when you're dealing with electricity. All right, we got that settled. Let's move on to the next thing. Now, on the 1224 output, most likely you're not going to be turning that generator with a vertical access homemade set of fins on it. You probably won't max out the RPMs to reach 24 volts. So you'll probably be dealing with around 12 volts. So what you're going to do is you're going to be, with that connection coming through your gauge, going to your batteries, you'll see your readings here. Now you don't want to overcharge your battery, so you've got to have something that's going to take the extra voltage away once the batteries are fully charged. A fully charged 12 volt battery is around 12.6 volts, okay? So to charge that battery, you've got to put in more than 12.6 volts. Otherwise, it's got a blockage. It's found a dam. It's met its resistance. It can't go any further. So most generators and that kind of stuff, and alternators on cars and so forth, all put out over 13 volts. And it should be anywhere from like 13.1 volts all the way up to 14.2 or 14.3. That's the maximum you want to put into a battery for charging. But then, once your battery reaches its full peak, and you go a volt over from 12.6 to 13.6, well, you got to use up some of that electricity or you're going to start damaging your battery. So that's what this thing is used for. Okay, now this is a charge controller, but it is not connected to the input of the PMA or the generator. It is not coming from controlling the input. What this does, this is connected to the battery. So here's a positive here, and well, I've got my board up here so I could write on it. The negative goes back there to the negative side of the battery. All right, and then it's got a positive wire here. That I know it's black, but I put a red end on there so I know it's positive. You got a positive here that comes and goes up to a load. This is a resistant load. All right, and then you got the negative that goes down to the battery. So what happens is when the voltage in these batteries reaches 14.2, that's what I've got it set for. When it reaches 14.2, as soon as it tries to go over 14.2, then this thing kicks on like this. You see the little light. I've got a fan connected here to keep the solenoid cool because they will get hot from being held together. So that comes on automatically when that happens. And then that sends electricity, the extra electricity, to that heating element, and then that heating element starts heating up, and it like it's doing right now. Okay? I'm going to shut that off because I don't need it right now. I'm only at 13.9 volts. Oop, I'm at 14. So anyway, that's what you're going to do, is you're going to put a load resistance application like this. And I sent you a couple of links in email on different ones that they buy. Now they're not using these PWMs much anymore, and they're really hard to find. They're using digital controllers up here, but they still have the solenoid in between. And then they have other digital controllers that get really expensive. For your project, I think you'd be okay with the links that I sent you to use the ones that they have there. And all you're going to do is, I know you don't want to buy a resistor. This is a 300 watt resistor. I'm sorry, this is a 500 watt resistor. And this 500 watt resistor is a little on the expensive side. So what you could do is, instead of connecting it to this across a resistor like that, you can put a series of 12 volt light bulbs. And don't use LED bulbs because they don't use enough voltage and amps to lower the electricity. You want to use the old incandescent type light bulbs that they use in automobile tail lights and things like that in the older cars. And you can buy those with little sockets where you could just solder the wires to the positive and negative poles of the little light bulb, and tie those in series so that you can up the amount of draw that you're drawing on it. Like I said, because you're going to be most likely doing this in a controlled environment using a electric fan to provide the wind to turn your turbine and produce electricity, you probably aren't going to generate high voltage like I do here. Now you can see here, this side here is amps peak, that's watts peak. So I've already produced over 1,018 watts in this thing at almost 66 amps of electricity. That's a lot of power. And I have to have this dump load system on here to make sure I protect my battery banks. You'll be working with one battery and so forth and so on, so you'll be fine. All right, I hope that clears up all your questions that you have. I did put this board up here so that I could draw things on there, and I don't really need to go any deeper into anything. I hope you guys are all doing well with this lockdown and your online studies. And if there's anything else I can help you with, you just feel free to drop it in my comment section, or you have my email. Just go ahead and email me. Let me know what you need to know. Very simply put, like I said, you're going to take your generator, and you could take that generator and take 2 wires and go directly down to your battery. The only reason I say to get a meter like this one, I'll get a little closer so you can read what it says on there. Okay. The only reason I say to use a meter like this is so that you can see what it's doing. All right. And now, one of the dump load controllers I sent you actually has a little meter on it, but it's not going to tell you watts and that other stuff. It's going to tell you how many volts is running through it. It's just a voltmeter. This is a multimeter, and this is what you want. They get fancy and they call it a watt meter and power analyzer, and they're not expensive, so don't spend a lot of money on it. There's really no need to, but you're going to be saving money on not having to buy a PMA controller or a solar controller, because it'll do you absolutely no good in your wind turbine setup. All right, if you do go change your generator to an alternator, you will need to get a rectifier, and this is called a bridge rectifier, and it takes AC voltage from the alternator up there. That's 3 wires coming in, and they're all hot. And then inside of this unit, using electronics, it converts it to DC with a positive and a negative, so you can go down to your battery. That's all there is to it, people. But if you do use one of these, make sure you get it with a heat sink on it. I have a backup one here. This is a cheaper model, and it comes with its own built-in heat sink to relieve temperatures. You will not need this, and you will not need a heat sink with a generator. The motor that you showed me, or the generator that you showed me that you're going to be using. You don't need a rectifier. It's already built into the system right inside of the closed case of the generator. All right. That's all there is to it. Like I said, any questions, feel free to drop them down at the bottom here in the comment section. And hey, do me a favor, have a couple of your friends and other students subscribe to my channel. I could use the subscribers. I live off grid completely, and I earn some of my working capital through my YouTube channel. So your help is appreciated. Good luck, Matt. Good luck, Jason. And good luck, Emma. Hope your project turns out well. G-Bear signing off.